great. 2 weeks off, great Christmas break. And what we're doing today is we are starting factoring. Well, starting is not the correct word because we've done factoring before. Yes, because we did this with quadratics. We touched on it a little bit with our higher degree polynomials. We will hit that again, going over solving, or not solving, but factoring sum and difference of perfect cubes. We didn't get to factoring by grouping, but we will get to it this time. But we're doing factoring again. Now, the main reason we're doing factoring again is because when we start solving rational equations, factoring is a key part of it. Because when we look at a rational equation, and you don't have to write this down because we're not going to cover this at this point. Solving equations like this here, if there is something in common on top and bottom, there is a factor of the denominator that is shared by the numerator, we would need to be able to determine what it is and simplify it out. Luckily for this one here, the denominator is not factorable at all, so there is no like terms, and we could go on and solve it from here. So in order to do that, we're going to go back over factoring. Also, the reason we're starting off with this here is because, well, we're first day into the new semester. Instead of jumping in and covering completely new stuff, we're just going to go back over factoring before we get into the new chapter. Now, when we factor quadratics, our first main step is our greatest common factor. Because whenever we factor a quadratic, or really any higher degree polynomial function, we should always look for a greatest common factor first. If there is something in common with all three terms here, or any of all the terms, we'll factor it out. If there is no greatest common factor, we move on to step 2. Our two sets of parentheses with 3 spaces. Now, if you want to write the 3 spaces, you can. It's not necessarily necessary to do that. The main reason I do include the 3 spaces is it just makes sure that when we do write our sets of parentheses, we don't write them so small that we can't fit everything in. So it just gives us enough space to put everything down. Questions on this so far? Step number 3 is our signs. Bless you. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. The signs are opposite. So we're talking about signs. The only time we really look at the sign of the middle term is if the third term is positive. If the third term is positive, the signs will be the same and match the sign of the middle term. If the third term is negative, the signs are automatically opposite. And luckily, out of all the problems today, this one's going to take the longest, mainly because we're writing these steps down, not so much in actually doing the problem. We ready to move on to actually applying step number 3? Yes?
What's the red third letter?
Third? Yeah, so this should be third. Third. If the third term is negative, then the signs are opposite. And that should be then. And the signs are negative, opposite. And I realize I'm missing a few words when I wrote. But if we look back at this here, b squared plus 12b plus 20. If the sign of the third term is positive, then the signs are the same and match the sign of the middle term. If the sign of the third term is negative, the signs are opposite. Well, here the sign of our third term, our constant term, is positive. So the signs are the same and match the sign of the middle term, which is also positive. So in this case, we'd have plus and plus. Questions on this here? Okay, that takes care of step number 3. Step number 4. Find the factors of the first and third terms. And we can go on and do the last step, which is plug and check. Plug and check. Plug them in and check them. Plug them in and check to make sure those are the correct factors. We're ready to find factors, plug and check. So let's scroll back up. So if we look at this here, factors of the first and third term. Factors of our first term are the factors of b squared. B and b. Those are the only factors of b that we're going to be able to use. The number in front of b squared is 1. So that doesn't impact this at all. So we just have b and b. There's only one set of factors for b squared. Anytime first and third terms factors, we only have one of them, we'll just plug them in and we can go from there. 20. Factors of the third term. Unfortunately or fortunately, there's more than one set of factors for 20. Because our first one is 1 and 20. 2 and 10. 4 and 5. So factors of 20, we have 3 of them. Which one do we want to try first? 2 and 10. So we plugged it in, and the last thing is to check it. Now we could multiply this all the way out and do b times b first. Well, what is b times b? B squared. Well, where did we get b and b from? B squared is factors of b squared. So we should be able to multiply those back together and get back to b squared. So there's not a whole lot of reason to actually multiply those out. We could also do our positive 2 times positive 10, which is our positive 20. Well, we got 2 and 10 from the factors of 20. It's not wrong to do those 2 multiplications when checking. It's just not necessarily necessary to do those because, well, that's where we got them from. The only times I would would advise to do that is if you're not feeling comfortable with those factors or making sure you got them right, you can go on and multiply them just to make sure. But the ones we do need to check are b times 10 and 2 times b, because this is the one that changes depending on the factors. Our b times 10 is 10b, and it would be positive. Our 2 times b would be plus 2b, and our 10b plus 2b is 12b, which is the correct middle term that we wanted. So b plus 2 times b plus 10 is our final answer. Questions on this here? Are you ready for the next one? A squared plus 4a minus 32. Because that would be the general form of quadratics. Ax squared plus bx plus c. Here, is there a greatest common factor between these three terms? Because we do have the square with a squared.
100%.
So there's not an a in all three, and the number in front of a squared is 1. So there is not a greatest common factor between these three terms. So we can move on to step 2. Our 2 sets of parentheses with 3 spaces. Our next step is to find the signs. Yes. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. And since the third term is negative, our signs are indeed opposite. One's positive, one's negative. Which one we make positive and which one we make negative really doesn't matter at this point, because again, our last step is to check. So we will check it at the end and see. And if we remember back to last semester, when we check it and we get the wrong sign but the correct number, all we got to do is flip the signs. So we just need to plug this in at this point. Which brings us to our next step, our factors of the first and third terms. Factors of a squared are a and a. There's only one set of factors for a squared. It is a and a. Now we say that, I mean, we could say 1 and a squared, yes? Because that is technically factors of it. I wouldn't write it down for this here because I'm going to show you why this doesn't work. Because we could say a squared and 1, and I'm just going to pick a set of factors for 32, 1 and 32, yes? But that second set of parentheses, we have what? 1 minus, those would combine, yes? So negative 31 times a squared plus 1, and if we multiply this out, a squared times negative 31, negative 31a squared. Is that what we had to start with? No. So we can, without doing the rest of it, it doesn't work out. The only way that we could have a squared as a factor is if we had a power bigger than a squared to start with. So for the most part with these quadratics, our first term a squared is going to be a and a. Could it work out that one of them is a squared? Yes. But for that to work out, we couldn't have a squared. We'd have to have a to the 4th or a cubed. We'd have to have a higher power. It does work that we could have a squared and a squared. But the term here would have to be a to the 4th, and our a here would have to be a squared. One more. There we go. So a and a. Factors of 32. 1 and 32. 2 and 16. 3 doesn't work. 4 and 8. 5 is not a factor of 32, because that would give us 5 and 6.4. And at that point, we're pretty much done, because 6 is not a factor. For 6 to be a factor, both 2 and 3 have to work. 3 doesn't work. So these are all of our factors. Now, which one of these do we want to try first? 4 and 8. Which one do we want to put first? Okay. 4 and 8. We can do 8 and 4. Either one works. Because the last thing we need to do is check this here. Because again, we could still do a times a, which would give us a squared, which is what we want. But we can do a times negative 8, which is negative 8a. Then do our 4 times a, which is positive 4a. And negative 8a plus 4a is negative 4a. I mean, we could continue on doing 4 times negative 8, which would indeed give us our negative 32. But again, the main thing we're focused on is the middle term. Is that the middle term we wanted? No, it's not the exact term we wanted, but it is close. Because instead of it being negative, we need it to be positive. We got the correct number, but wrong sign. And anytime we get that, we just need to change the signs. And if I check this again, 8 times, or a times positive 8 would be positive 8a. Negative 4 times a would be negative 4a, giving us positive 4a. So a minus 4 times a plus 8 is the correct answer. Questions on this here? Are you ready for the next one? X squared minus 11x plus 72. Is there a greatest common factor between these three terms? No. So we'll have 2 sets of parentheses with 3 spaces. One of the giveaways is the fact that there's not a number in front of x squared. Because if there is, there's a chance there is a greatest common factor. If the only number there is 1, there's a good chance there's not. Because if there's not a number there, we're looking for a variable greatest common factor. 72 does not have a variable, so there is none. Now we look for the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here it's positive, so they're the same and match the sign of the middle term, which would be negative and negative. Questions on this so far? Factors of our first and third term. Well, factors of x squared are x and x. And now we need to find the factors of 72. Well, I'd always start with 1 and 72. 2 and 36. 3 and 24. 4 and 18. 6 and 12. 8 and 9. And again, with finding factors, especially for the bigger numbers, I'd start with 1 and 72. And then we can divide it by 2 because 72 is even. It is divisible by 2. It is divisible by 3 because the sum of the digits is also divisible by 3, 7 and 2. And then we can divide it by 4 and get 18. 5 doesn't work because it doesn't end in a 5 or 0. 6 does work. Yes, we can try 8 and 9 first. And the last thing we need to do is check this. 8x times negative 9 is negative 9x. Negative 8 times x is negative 8x. And negative 9x minus 8x is negative 17x. And that's it. Questions on this here? Questions on anything we've done so far? Get ready for the next one. How do we feel with these so far? Starting to come back to us a little bit? Right. We'll do one more like this. Do we want to do this one here or the number 11, 10 or 11? 10? Yep, we'll do this one here. Pretty much. Is there a greatest common factor? No. There's not a number that goes, or variable that goes in x squared, 7x, and 30. Yes, because that's what we're going to do for the next one. So I have two sets of parentheses with 3 spaces. Our signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here, since it's negative, our signs are positive and negative. Questions on this so far? Now we need to find the factors of the first and third terms. Factors of the first term are x and x, because our factors of x squared here are always going to be x and x. If there was a number in front of it, we would still have x and x. We would just need to find the numbers in front of x. Now we need to find the factors of 30. We'd have 1 and 30. 2 and 15, 3 and 10. Is 4 a factor? It is not, unfortunately. 6 and 5 are factors, or 5 and 6. Either way works. And we get this here. Which set of factors do we want to try first? 3 and 10. Which one do we want to put first? So we can put 10 first. It really doesn't matter. We could put 3 first. We could put 10 first. It's up to us to choose. Now when we check this here, x times negative 3 would be negative 3x. 10 times x would be positive 10x. And negative 3x plus 10x is 7x. So here we indeed did get the 7 that we wanted, but it's the wrong sign. So to fix that, we're going to switch the signs. And if we wanted to check it again just to make sure, x times positive 3 would be 3x. Negative 10 times x is negative 10x, giving us the negative 7x that we wanted, telling us our factors of x minus 10 times x plus 3. Now if we had listed it as x plus 3 times x minus 10, that is still the same answer, it's just written in a different order. Because the nice thing with multiplication is we can multiply any two expressions in any order. Questions on this here? All right. We're going to skip our p squared plus 15p plus 50. If we did work that out, we would get p plus 10 times p plus 5. And look at this one here. 2r squared plus 6r minus 8. So this is the first one here where we do have a greatest common factor. And the greatest common factor is indeed 2, yes? So what we're going to do first is factor out the 2. And whenever we factor out a greatest common factor, realistically, what we're doing is putting it in front and dividing every term in the expression by that amount. So if we divide 2r squared by 2, we're left with r squared. When we remove 2 from 6r, we have 3r. And when we remove 2 from negative 8, we have negative 4. We're just dividing each one of them by 2. Now, since we didn't remove a negative, the signs stay the same, positive, positive, negative, and we get this here. Now, we can again look back and see if there is any other greatest common factor, which there's not, because we just have r squared. Because if you're having trouble seeing what the greatest common factor could be, remove any that you think are a common factor, and then just making sure there aren't any left. Now the rest of the steps stay the same, because once we remove the greatest common factor, we go to our 2 sets of parentheses with 3 spaces. So we have this here. Then we look at our signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here, the third term is negative, so our signs are opposite. One's going to be positive, one's going to be negative. Questions on this so far? Factors of the first and third term. Factors of r squared are and r. Because those are the only factors of r squared, and since the number in front of it is 1, we really have 1r and 1r, but r and r is the same. And hopefully you got a good bit of it over the last 2 weeks. Now the other one we need to find the factors of. Rest and recovery, rest and relaxation. Factors for 1 and 4, 2 and 2. Which one do we want to try first? 1 and 4. Because if we did do 2 and 2, the middle term would actually be what? 0, because we'd have positive 2r and negative 2r. So I heard 4 and 1. We could do 1 and 4. Because again, our last step is to check. R times negative 1 is negative 1r. 4 times r is plus 4r, giving us positive 3r. Is that the one we wanted? Yes. And that's it there. Questions on this here? So is this any real different than what we've done before? Yeah. Let's look at number 9. If you're wondering, yes, the numbering is jumping all over the place. So, yeah, it is still 6. And that is a good question. Because the question is, shouldn't it have been 6? Well, it is still 6. But because we pulled that 2 out, we're not looking at 6r anymore. We're looking at the 3r. And if we did distribute it back through after we multiplied, it would turn it from 3r into positive 6r. Because once we factor that greatest common factor out, we're not looking at the original problem anymore. We're looking at the one after we pulled it out. So here, what is the greatest common factor between 4x squared, 20x, and 56? It is 4. 2 is a common factor, but it's not the greatest common factor. And in some of the cases like this here, if you do see 2 but not 4, we could factor the 2 out and look at it and see if we can factor another 2 out, which we can. And we factor the 4 out of 4x squared, we're left with x squared. minus. When we factor 4 out of 20, we're left with 5 in our x. And 56, when you factor the 4 out, is not 9. Because that would have been 40 is 14, because 4 times 9 is 36, not 56. Now, one of the things I will remind y'all is, especially on the homework, if there is a greatest common factor, you do have to include it as part of your answer. So you do need to make sure to leave it out front. It just stays out front the rest of the way down. Now, on solving, if we were solving it, we don't need the greatest common factor because we're just trying to find out what values of x makes the function equal 0. It's just a scalar at that point. Here, it's still part of the answer. Does that make sense? Now, next step is to find the sign. They're going to be opposite. Since the third term is negative, our signs are opposite. If it had been positive, the signs would have been the same and matched the sign in the middle term. Factors of the first and third term. Factors of x squared are x and x. That's the only factors of x squared. Factors of 14. 1 and 14. 2 and 7. 3 is not a factor of 14 because it'd be 3 and 4 point a decimal. At that point, we're done. Because the only other one after that would be 4, and it's going to be 3 point. So we can use 2 and 7. And I just stuck them in 2 and 7. And the last step is going to be to check. X times negative 7 is negative 7x. 2 times x is plus 2x. And negative 7x plus 2x is negative 5x, which is the middle term we wanted. So this here is our final answer. Questions on this here? Right?
That was what I had originally.
Plus 2, oh, so x plus 2 times x minus 7? It might have been just a sign calculation. Does that make sense? Yeah. Huh? Where if we had something other than 2 and 7, or? So if we did 1 and 14, x times negative 14. So the question is if we did the wrong factors, and we could see this here. So 1 and 14. So x times negative 14 would be negative 14x. 1 times x would be x. Negative 14x plus x is negative 13x, which is not the middle term we wanted. Now at this point here, the first thing I would do is switch the 1 and 14, just to make sure the other arrangement didn't work. But here, since we only have x and x, it's almost the same as switching the signs, which would have just changed it from negative to positive. Now we would switch the 1 and 14 if, even if it had just been 2x and x or 2x and 3x, that can give us different values because of the 2 and 3, and then we would try it. If both of those didn't work, then we would move to the next set of factors. Does that make sense? And we will do those tomorrow, where we're going to have an a different than 1. Because here, in some of the problems we have, the a value is different than 1, but after our greatest common factor, it goes back to being 1. The number in front of x squared is 1, and we get back to this here. Questions on this here? I do want to look at 2 more. I want to look at this one here for sure. Actually, we'll look at 3 more. This one, the one after it, and the last one. The last one's going to take the least amount of time for all these. 3x plus x squared minus 10. Yes. That's part of the reason I want to look at this here is it's written in the wrong order. Because we really want these to be written in standard form. X squared plus 3x minus 10. So we can just reorder these here. Since there's no sign in front of the 3x, it's understood to be positive. And since we have plus x squared, we know it's positive. When we move it to the front, we don't have to write plus x squared. But we do need to write plus 3x. There is no greatest common factor between x squared, 3x, and 10. 2 sets of parentheses with 3 spaces. Yes. Since the third term is negative, our signs are opposite. One's going to be positive, one's going to be negative. Factors of x squared are x and x. Factors of 10. 2 and 5. We're going to do 5 and 2, and I intentionally put the 5 first. Because when we check this here, x times negative 2 is negative 2x. Our 5 times x is positive 5x. Negative 2x plus 5x is positive 3x. So those are our factors. Questions on this here? Questions on anything we've done so far? Okay. Are you ready for the next one? Yes? Well, okay. I'm going to have to write the next one in. Our 9x squared plus 30x plus 6. Looking at this here, is there a greatest common factor? 3, yes? And we can factor it out. Because if we factor 3 out of 9x squared, we have 3x squared. Factor 3 out of 30, we get 10. And if we factor 3 out of 6, we get 2, yes? And actually, this is as far as it goes. Because we were really looking at the factors of 3 and 2 to try to get 10, which actually doesn't work. And a way we can check to see if something is factorable is our square root of b squared minus 4ac. If we get a number that is a decimal or I, if we use the 30xs, it'll give us an error if it would have an I. It'll tell if it's factorable. So here, our b is 10. Our a is 3. And our c is 2. For a, b, and c, we do take the signs with it. So we're looking at the square root of 10 squared minus 4 times 3 times 2. Square root 10 squared minus 4 times 3 times 2, which gives us 2 square root of 19. That's a decimal. Because if I converted the radical, it's 8 point this here. So what that's telling us, that is completely factored. It's not that it's not factorable, because there is a greatest common factor of 3. We can factor it. It just doesn't factor from there. Does that make sense? That's as far as it'll go, yeah. there's a good, because one is that we could do our two sets of parentheses, do our fact that plus third term is positive, so the signs are the same, match sign of middle term. We'd still go through the steps. And looking at the factors at 3 and 2, there's a good chance 3 and 2 isn't going to get us to 10, and we could go through all the factors for those there, and it just wouldn't get us there.
So, if neither one of the things that you can factor will get the middle term, then just do that.
That there's just a check. A way, is it, because looking at it, and this is some just doing it long enough, it looks like the middle term's a little too far away from our factors of the other two. I'll jump to that and just check and see. Well, so if we get 1, 2, 3, 5, 7, we get one of our counting numbers, then it is factorable. We can keep going. And I think the last one is what? So this does look like it can work. I'm just going to go on and plug it into the quadratic, or the, 9 squared minus 4 times 2 times 5, square root of 41, decimal. So this is actually not factorable, because that is as far as it goes. There's no greatest common factor between the three terms. It's can't factorable, so we just say not factorable. We're done there. Does that make sense? Now this, it is possible to make this one factorable, but to do that, it needed to be -2, not +2, for it to work. Now, the reason I did include those is because one of the problems on this worksheet is not factorable. And if you do get that, you just put not factorable. There is one of them on the worksheet that just has a greatest common factor. Factor it out, and then that's your answer.